Okay, here's problem number 1 from assignment number 7 from the winter break packet. We're asked to find the absolute max and min for this function on this closed interval. So we are going to use the closed interval method. Now the closed interval method means that we're going to find all of the critical values of that function on that interval, and we're also going to test the endpoints. And then one of the values of the function at either the critical values or the endpoints has to be the absolute max, and one of the other ones has to be the absolute min, as long as the function's continuous, and this function is. So let's find out what the critical values of this function are by taking its derivative. The derivative of 2 sine theta is 2 cosine theta, and the derivative of negative cosine 2 theta is going to be positive sine of 2 theta multiplied by an additional 2. All right? Now, normally we would say, okay, let's set that equal to 0. But we've got a problem in that expression. We don't have any really good analytical tools just to look at that expression. So we're going to have to break out a trig identity in order to get this to work better. And the trig identity that I'm going to use, I'm going to get rid of the sine of 2 theta, and I'm going to replace it with what it's equal to. All right? So I'm going to get 2 cosine theta, and I'm going to replace sine of 2 theta with 2 sine theta cosine theta. And of course we got to multiply that by 2 as well. So why would I do that? Well, what's going to happen is I get my 4 sine theta cosine theta is now I can actually factor that expression. I can factor, remember we want to set it equal to 0. I can factor out a 2 and a cosine theta out of that expression. And what it leaves me is a 1 and a 2 times sine 2 times sine theta. And now it's easy to see what values of theta will make this 0. The values of theta that makes this 0 are the values of theta that make cosine 0. And theta is 0 when cosine is pi over 2 and 3 pi over 2. Are we all in agreement there?
Yes.
All right? And where 1 plus 2 sine theta is equal to 0, which is the same place where 2 sine theta is equal to negative 1, or that sine of theta is equal to negative 1/2. Now that one's a little bit harder to recall. Okay, I'm going to draw up my reference triangle. You guys probably don't use reference triangles, but this is my 30, 60, 90 reference triangle, and I'm looking for a sine of 1/2, which happens with this angle, and that angle happens to be pi over 6. All right? This is the pi over 6 angle. Now the second thing I say, I need to know where sine is negative. Oh, that's going to happen here and there. So I've got that angle, which is pi plus pi over 6, which is 7 pi over 6. And then this angle, which is 2 pi minus pi over 6, which is 11 pi over 6. So there are a list of all the critical values for this function on this interval. And now we're going to make a list, find the values of the functions at all the candidate points, and declare who our winners and losers are going to be. Meng?
Okay, for this question, we need to know the trig identities, and we have to know like sort of where the unit circle is?
I think that's an excellent question. Let me tell you what I think is fair game and what's not fair game. This particular trig identity, the one that allowed me to find that, typically doesn't show up in the AP exam, and I will not give you a problem that has that kind of idea. All right? The only trig identities I'm asking you to memorize for class are the Pythagorean identities. Okay? So I would say the thing in red is probably, I'll put it under the heading of a trick and need not be memorized. And now it was nice that it helped us out, but it's atypical for AP problems. Me being able to discern these two values though, no, those are absolutely fair game. All right? Is that fair?
Yes.
All right. Yeah, Ben.
Since this is a closed interval, are the endpoints?
The endpoints are also candidates. So our first question will be, well, what's h of 0? And so h of 0 is going to be 2 sine of 0 minus cosine of 0. Sine of, oh, I wrote sine of theta there. I meant to write sine of 0. Let me change that. Sine of 0 is 0, and cosine of 0 is 1. So this expression is negative 1. Okay? 1 down, 5 to go. Are you ready? What's the next one we want to try? What do we do in increasing order? How about h of pi over 2? Which is going to be 2 times sine of pi over 2 minus cosine of pi. Double check that I did that right. Yeah? Okay. What do we get? Sine of pi over 2 is 1. 1 times 2 is 2. Minus cosine of pi is, I think that's negative 1. Starts at 1, then 0. I think that's negative 1. So this is minus a minus 1. So this gives me a 3. You'll correct me if I make a mistake, won't you? Yes?
Okay, I see. Yeah.
Are you sure?
Yeah.
All right. What's my next value? H of 7 pi over 6, which is 2 sine of 7 pi over 6 minus cosine of 7 pi over 3. Okay, well, we just found out that sine of 7 pi over 6 is negative 1/2. So this is 2 times negative 1/2 minus, now what's cosine of 7 pi over 3? It'll be the same numeric value as of cosine of pi over 3, which is going to be cosine, which is going to be positive 1/2.
Yeah.
Because here's my pi over 3 angle, so it's going to be 1/2, and 7 pi over 3 puts me in the first quadrant. Is that right? Because I go from here, I go all the way around to 6 pi over 3, and then 7 pi over 3 is in the first quadrant. So it's positive 1/2. So I end up getting negative 1 minus 1/2. I'm going to get 3/2 there. Negative 3/2. Good, thank you. All right. The next one in order is going to be what? 3 pi over 2. So 2 times sine of 3 pi over 2 minus cosine of 3 pi. Okay. Sine of 3 pi over 2 is negative 1. So this is negative 1 times 2 is negative 2 minus cosine of 3 pi is no, negative 1. Because it goes 1, negative 1. Wait. No, it's negative 1. It's negative 1. So this is a minus 1. Is that right? Which means we get negative 1 there. Okay, got 2 more to go. H of 11 pi over 6 is 2 sine of 11 pi over 6 minus cosine of 11 pi over 3. Now again, we already know that sine of 11 pi over 6 is negative 1/2 because we calculated that over here. So that's negative 1/2 times 2, that's a negative 1. And then this is going to be a 1/2, and we're at what, 11 pi over 3. 11 pi over 3. So that's 1 pi, but this is equivalent to what? 3 and 2/3 pi?
Yeah.
So 1 pi, 2 pi, 3 pi. We're in this quadrant where cosine is negative. So this is going to be a negative 1/2. This negative from that, and this produces a negative cosine value. So this ends up being,
Isn't that what cosine's positive?
All students take,
Oh,
should be negative.
no,
Oh, that's-
take calculus. So I think cosine is negative there. I think.
Well,
Yeah.
I think it's in the fourth quadrant.
It's 2/3 to be passive.
Oh, my own. Oh, you're right. I'm in this quadrant, aren't I? Oh, good. That's really good. So this is negative 1 minus 1/2, which is going to be negative 3/2. Thank you. That saves my bacon.
So,
And bacon is delicious.
how do you get negative 1/2 from?
Okay, so
I don't know how it does.
11 pi over 3.
I know how it goes like around twice and a half. But I know how to get to that point.
Okay.
How do you get that angle?
Okay, let me. Okay, 11 pi over 3. Here's 3 pi over 3. Here's 6 pi over 3.
Yep.
Here's 9 pi over 3. Now I've got another 2 pi over 3 to go. Here's one of those pi over 3s. Here's the second. One 60-degree angle, another 60-degree angle. That puts me squarely in the fourth quadrant, which means that this value has to be a positive cosine, so minus this positive value.
Why 1/2?
Yeah, that's what I was asking.
Because after you ignore the 11, it's a pi over 3. So it's essentially the cosine of pi over 3, and you just look at the extra stuff to determine whether it's positive or negative. You've never used that trick? Oh, okay. That's a new trick then you can use. All right. And then we got one more to do, which is h of 2 pi, which is 2 sine of 2 pi minus cosine of 4 pi. Cosine of 2 pi is 0, so this whole thing goes away. Cosine of 4 pi is the same thing as cosine of 0, which is the same thing as 1. So this ends up being a total of negative 1. All right, and now we can declare our winners and losers. Where's the largest value in all of this mess? At pi over 2. So we say that the absolute max for this function on this interval is 3. Where's the lowest value in this mess? Negative 3/2. So we would say that negative 3/2 is the absolute minimum on this interval. And then we do one last thing. And this is something I really hope that you would have been doing while you were doing this assignment over winter break, and that is break out the calculator and check your answer. Does this answer make sense? Does it look like we got the right value? So here's my calculator. I'm going to go into graphing mode. I'm going to put in my function, which was, I've forgotten already, 2 sine of theta minus cosine of 2 theta. All right? And then let me restrict my window. Let me restrict my window to the interval that we were working on, which was 0 to pi. All right? So there's our function. does this look like this has that value of 3? Now, granted, this is 2 pi, right? This is 2 pi, so pi is about here, and wasn't it at pi over 2 that we said that the maximum was 3? So that looks about right. Hey, didn't we get negative 3/2 twice? Okay, and then of course we can go ahead and use stuff that we used to use in your earlier classes. If we say, what's the maximum? Come on, lower bound. Try that one more time. Analyze graph. Find the maximum. Analyze graph. Find the minimum. And you can see that we have exactly those maximum and minimum values found. Okay? So I think we did it. I think we really did find the absolute max and min on that interval for this function. And given that, we're going to close this recording.